You are standing at the base of the Great Pyramid of Giza. Above you, more than 5 million tons of limestone, stacked into the largest stone structure ever raised by human beings. For almost all of history, there were only two ways to find out what was inside something like this: find a door, or break a wall. A team of physicists found a third. They used particles created several kilometers above your head, particles that fall through the sky constantly and pass straight through solid rock, to look inside the pyramid without touching it. What came back was a space at least 30 meters long that appears on no plan, in no survey, in no record. Nobody has ever been inside it, and nobody knows what it is. To understand why that is such a strange sentence, you have to understand how well we thought we knew this building. The Great Pyramid was raised for the pharaoh Khufu in the 26th century before the Common Era. Each side of its base runs about 230 meters. It originally stood close to 147 meters tall, and it held the record for the tallest structure on Earth for more than 3,000 years. It contains something like 2.3 million blocks of stone and a total volume of around 2.6 million cubic meters. Almost all of that is solid rock. The interior everyone knows about is remarkably small. A descending passage, an ascending passage, a room called the Queen's Chamber, a room called the King's Chamber, still holding an empty granite sarcophagus, and running between them the Grand Gallery, a steep corridor about 47 meters long and 8.5 meters high, with walls that step inward as they rise. Add every known passage and chamber together, and it accounts for a tiny fraction of the pyramid's volume. Those spaces were entered more than 1,000 years ago, and then surveyed in obsessive detail by European archaeologists generations later. Every wall measured, every joint recorded. The conclusion was simple. We had the map. The problem is that a map like that can only ever describe what somebody has already walked into, and there was no way to check the rest. You cannot X-ray a mountain. Medical X-rays are stopped by a few centimeters of bone. Ground-penetrating radar fades out after a few meters of dense stone. In the middle of the Great Pyramid, you are dealing with 60 meters or more of limestone in every direction, and every technology powerful enough to see through that would destroy the thing it was looking at. So the interior of the most studied building in the ancient world stayed, in practical terms, unknowable. Not because nobody cared, because nothing could reach it, except that something was already reaching it, constantly. And the first man who understood what that meant tried it and failed. More than half a century ago, a physicist named Luis Alvarez had an idea that sounded absurd. Alvarez worked at the University of California, Berkeley. He would win the Nobel Prize in Physics for his work on subatomic particles, and he had a habit of pointing his expertise at problems that were not his own. He proposed that the tools of particle physics could be used to hunt for hidden rooms inside the Egyptian pyramids. His reasoning was this: the Earth is under permanent bombardment from cosmic rays, high-energy particles arriving from deep space. When they strike the upper atmosphere, they shatter, and among the fragments are particles called muons. A muon is a heavy relative of the electron, and its useful property is that it barely interacts with matter at all. Muons pour down through the atmosphere, through buildings, through people, through solid rock, through stone, but not all of them. Alvarez secured permission to work at the Pyramid of Khufu, the second largest at Giza. He installed detectors in a chamber beneath it, recorded every arriving particle onto magnetic tape, and waited. The measurements ran for roughly 2 years, interrupted at one point by a war. Then he analyzed the data. There was nothing there. He had surveyed close to a fifth of the pyramid and found no unknown chambers. He published the result in the journal Science, and it stands as one of the most elegant negative results in the history of archaeology. Think about what that meant for him. A Nobel laureate had aimed the most advanced particle detectors on the planet at one of the most famous buildings ever constructed, waited 2 years for the sky to fill in the picture, and got back an empty answer. Plenty of people read that as the end of the question. If physics of that caliber could not find anything hidden, the reasoning went, then there was probably nothing hidden to find. But Alvarez made a point that outlived his result. Not finding something, he insisted, is not the same as proving it is not there. He had examined a fraction of one pyramid with the instruments available to him, and the instruments were the limit, not the pyramid. The field noted the idea and moved on. For decades, almost nobody went back. Then a team returned to Giza carrying detectors Alvarez could not have built. They pointed them at the largest pyramid of all, and within months, the data showed something that should not have been there. Here is what makes the technique work. Around 10,000 muons fall on every square meter of the Earth's surface every minute. You are being passed through by them right now. They are harmless, they are free, and they arrive from every direction in the sky. When a muon crosses stone, it loses energy. The more stone it has to get through, the less likely it is to come out the other side. So if you place a detector inside a pyramid, aim it upward, and count how many muons arrive from each direction over a long enough period, you can work backwards. Directions where the count is low are directions packed solid with rock. Directions where the count runs unexpectedly high are directions where something is missing. That is the entire idea. Count particles, map density. The technique is called muography, and it is used to look inside active volcanoes and damaged nuclear reactors for exactly the same reason. It is the only imaging method that can see through tens of meters of rock, and it works because the source is free and never switches off. It is slow. It needs months of exposure, but it does not require touching the structure at all. The collaboration that brought this to Khufu's pyramid was called ScanPyramids, run jointly by the engineering faculty at Cairo University and a French Heritage Research Institute working under the Egyptian Antiquities Ministry. A physicist from Nagoya University in Japan, Kunihiro Morishima, installed the first detectors. His were sheets of photographic film sensitive enough to record the track of a single particle, and he placed them in the queen's chamber, low in the body of the pyramid, aimed up through the mass of stone above. They sat there for months. When the films were developed and analyzed, there was a line in the data that nobody had expected, an excess of muons arriving from one direction high above the detectors, as if a large part of the pyramid in that direction simply was not there. That is exactly the kind of result you do not announce. So 2 other groups were brought in, using completely different hardware. A Japanese high-energy physics laboratory installed electronic detectors in the same chamber. A French atomic energy research team placed gas detectors outside the pyramid entirely, looking in from a different angle. 3 technologies, 3 independent analyses. All 3 found the same thing in the same place. Above the Grand Gallery, buried in the solid body of the pyramid, there is a large empty space. Its cross-section is comparable to the Grand Gallery itself. Its minimum length is 30 meters. The team published the finding in the journal Nature and named it the ScanPyramids Big Void. It was the first major internal structure identified in the Great Pyramid in more than 100 years. It is worth being precise about what was actually proven, because the headlines were not. What the muons show is a large region of low density. They do not show a room. The exact geometry has not been determined. The void could be horizontal or inclined. It could be a single space or 2 or several smaller ones in a line. Nobody has seen it. So what is it? Aidan Dodson, an Egyptologist at the University of Bristol, who studies ancient Egyptian tombs, was blunt about the most exciting possibility. He put the chance of a hidden burial chamber at 0. The pharaoh's burial chamber is already there, with a sarcophagus in it. His own proposal is less romantic and considerably more interesting. The void may be a relieving space, an empty volume built deliberately to take the crushing weight of masonry off the grand gallery below. That is not a guess about Egyptian engineering. It is a documented technique. There are relieving chambers stacked above the king's chamber in this same pyramid, and in the pyramid built by Khufu's father at Meidum. Colin Reeder, a geologist and engineer who has studied the pyramids independently, has pushed back on that reading. He argues the void sits too far above the grand gallery to be relieving its load. His alternative is a question, rather than an answer. The grand gallery leads somewhere. It leads to the king's chamber. If this new space is built like the grand gallery, might it lead somewhere too? Mehdi Tayyubi, who led the collaboration, raised the possibility that it is a second grand gallery, and was careful to present it as a possibility rather than a finding. And then there is the hypothesis that turns the entire story around. Bob Breyer, an Egyptologist at Long Island University, had spent years working with the French architect Jean-Pierre Houdin on a specific theory of how the pyramid went up. At its core was the claim that the grand gallery was never meant to be a corridor. It was machinery. A counterweight sliding down that steep, polished floor could have hauled the granite beams of the king's chamber, some of them weighing 80 tons, up into position. If that is what the grand gallery was for, then a gallery-sized space higher in the pyramid is not a mystery. It is a second machine. But the same data cut against the other half of their theory. Houdin and Breyer had also argued for a ramp running upward inside the pyramid's outer body, and the muon results gave no sign of it. Breyer said so publicly. He said the data suggested the ramp was not there, and that he thought they had lost. There is one more thing worth considering because it proves the technique was not a fluke. The same project found a second anomaly close to the north face, behind a set of enormous chevron-shaped blocks set above the pyramid's original entrance. Nobody had ever explained what those blocks were for. The muons said there was a space behind them. This one was shallow enough to test directly. Radar and ultrasound were run across the stones and found a joint. Through that joint, a team fed an endoscope, a camera on a flexible probe about 5 millimeters across. For the first time in 4,500 years, something looked inside. The camera showed a corridor roughly 9 meters long and about 2 meters across, with a ceiling of stones leaning against each other, and an interior that was rough and unfinished, nothing like the polished passages tourists walk through today. It is a separate structure. There is no evidence that it connects to the big void, and nobody has claimed that it does. What it proves is simpler, and worse for anyone who thought the map was complete. We are still finding corridors inside the Great Pyramid, which brings us back to the space above the Grand Gallery, and to the strangest fact in this entire story. We can locate it far more accurately than we can reach it. There is no known entrance. No passage on any plan leads toward it. The pyramid can be scanned from inside, from outside, and from below, by 3 different technologies at once, and the answer comes back consistent every time. And it is still sealed. But the reason it matters may not be what is inside it. Look at the pattern. A gallery-sized void directly above a gallery that may itself have been a lifting machine. A rough, unfinished corridor hidden behind the north face. Neither one decorated, neither one finished, neither one built for anybody to see. There is still no scientific consensus on how the Great Pyramid was built. 2.3 million blocks placed in roughly 2 decades with granite beams weighing as much as 80 tons lifted more than 50 meters above the ground. If the big void is part of how they did that, then there is nothing waiting inside it. The void is the discovery. For 4,500 years, everybody who wanted to know what was inside the Great Pyramid had the same two options: find the door or break the wall. Now, particles born in the upper atmosphere fall through the desert every minute of every day, and we read the shadows they cast in stone, and the pyramid gives up its geometry without a single block being moved. Egypt's most prominent archaeologist has said publicly that further work is underway inside the monument and that an announcement is coming. That work has not been published or reviewed yet, so there is nothing to evaluate. What has been published is this: there is a room-sized emptiness above the Grand Gallery. We know roughly where it is. We know roughly how large it is. And we do not know what it is for. If you could send one instrument into that space, and only one, what would you want it to look for? 4,500 years after the last worker walked away from the site, the largest space ever found inside the Great Pyramid is still dark, still sealed, and still doing whatever it was built to do.